project, we will be using the force of the gyre to transport our garbage to our collection facility. We will be using the force of the gyre in our project to transport the garbage to our collection facility. As the garbage is moved, it will hit the first pod and the boom, and then using the force of the gyre, it'll hit the boom, and since the boom is angled, it'll go along with the boom to the hole that is in a collection facility, and it'll be pushed in without the use of any electricity, which we can use for other uses. As the garbage is pushed into our collection facility, it will go through and be processed so that it is all clean and ready for transportation into our tube, which we have chosen a cloth bag, or in this case a tube, because its holes are small enough to contain the microplastics.
Here we have our hydraulic fins. We're using our fins to keep our other pod in place, while this pod has an anchor to keep it in place. As I push down on this syringe, the fin will move, and if I pull it back up, the fin will move the other way.
Our hydraulics work by having this part at the top moving, so that even if the prototype is in the water, we wouldn't have to put the hydraulics in the water, which helps it from corrosion and rusting and all that. When you press in on this one, it extends this arm of the syringe and moves the entire fin and the syringe that way. When you pull it back, it moves the fin back over.
The reason why we chose a cloth net and a cloth bag is because the cloth has such a tight weave that it will be really hard for any microplastic to flow through the cloth. So we have the cloth bag there to collect any of the suspended garbage, because if we didn't have it, it would just be collecting the garbage that was on the surface of the water. So the garbage would come up to the boom and it would hit any part of the boom. And since it would be on an angle somewhat like this, the current of the water, or the flow, would push the garbage into this little hole into our entrance to the collection center. And it would go in there and it would process through the collection center. And it would be stored into this cloth bag, which is a toque in our prototype. But again, we took the cloth bag because the weave is so tight that no microplastic should be able to get through it. And then once the bag is filled up, we will have it collected and brought to a sorting plant and sort through the garbage.
For our project, we have the anchor to make sure that it stays stationary, due to the fact that this part needs to be stationary so that the garbage can flow across in there. Stay all steady.
Geocath, established by the men standing before you. Fluid properties. There are three distinct groups of fluid pressure. The first is kinematic properties, and that is velocity and acceleration. As if you were to push it harder, it would move more. The second is thermodynamic properties, and this is density and pressure, to name a few. The third and final one is miscellaneous, which is basically viscosity. It is placed in the class of its own because it does not fit into the two groups above. We used fluid properties in our syringes by having viscosity, as the water is less viscous than something such as oil or syrup, which would be far harder to press along the syringe. And we are also using acceleration and velocity, as we can push it and it'll move faster over there. And then there's flow rate and viscosity. Flow rate and viscosity is where a fluid is depending on the bondage and size of the particles. The bondage between the particles is the amount that the little guys stick together, and the size of the particles depends on the atoms and what atoms there are. An example of viscosity is where syrup will slowly drip off of pancakes and waffles, whereas water would quickly run off. A way to test the flow rate of different liquids is the ramp method, where you take two liquids and you put them down a ramp, and less viscous will travel faster.
Density, the measurement of a relative heaviness. For example, a rock is more dense than a piece of crumpled paper, and a piece of gum is less dense than a glass mug. To calculate density, you would use the principle density is equal to mass divided by volume. Buoyancy, when an object is in a liquid, the force of gravity pulls it down. The liquid, however, exerts an opposite force called the buoyant force that pushes the object upward. Buoyancy is a tendency of an object to float when placed in a fluid. It also acts against gravity. Buoyancy is an important factor in some technologies. For example, ships are designed to float, safely all over the world.
Fluid pressure is the amount of pressure pushing down on a fluid or object. The deeper the fluid object gets, the more pressure it will experience. For example, if you are under 10 feet underwater, the pressure you will experience will not be as intense as if you were 100 feet down. Fluid pressure is used in many cases. It is used when a submarine goes diving. The submarine can only stand a certain amount of pressure, therefore, it can't go all the way to the floor of the sea. In our project, we aren't having a submarine-like vehicle, but more of a boat-type vehicle. So, fluid pressure doesn't affect us that much at all, though it still won't in other cases. We have hydraulics, and with the hydraulics they use fluid pressure to help hydraulics work. Hydraulics is a system that uses non-compressible fluid. With gas it is called pneumatics. Under pressure to move loads, it uses liquids in a confined place to transfer forces. It works with Pascal's law. When fluids are being compressed, they try to find a way out and they end up moving something. For example, in our project we are going to have hydraulic fins. We will use hydraulics to move the fins so that our pod will stay in one place.
This is our top view of our blueprint. So here we have our first little pod, and it's the living pod, and we'll have like a scientist kind of person living in there, and they'll be able to watch over all the cameras to make sure no animals get trapped or anything. And then here we have our boom, and it's on both sides of on both pods. And what it does is the garbage will flow along the boom until it gets to the collection pod, which is that one. And then it'll flow inside the collection pod. And inside the collection pod, it'll flow into this cloth bag. And the reason we used a cloth bag is because for like the really small microplastics, they'll have a harder time flowing through cloth than it would just like regular mesh.
The bottom hull of our pods are not as interesting as the top. They're still important as they will be a rounder surface because we won't be using the pods to move around as much as we will just be having them in a stationary area. We also have on the bottom fin, which will help us stay in one single area by swishing through the water. Also on the bottom is our net, which we will use to catch suspended minute pieces of plastic.
So we have living room, living pod, glass over top, so that they have light and they can grow their food. We have the boom, which is located right here to help the plastics and the garbage transfer across. We have our cameras to make sure that animals or anything don't get caught. And the blue parts right here, are all the solar panels, so that helps with the electricity. And they're the scientists testing. The garbage entrance to the collection area is right here. We have an anchor to make sure, because it's a stationary project, it'll stay where it is, but on this one. We have a cloth bag, which collects all of the garbage from the garbage entrance collection center.
This is side B of our blueprint. So again, we have the boom, which is right here, and it's just to travel or help the garbage travel across. And then we have our pods, and then up here we have the living pod again. And then we have our cameras to make sure no animals get caught, and if they do, we'll have someone go out and help them. And then over there we have our anchor, and that's, again, keeps the one pod stationary. And then we have our cloth bag to collect the garbage, and our solar panels to provide electricity inside of the living pod.
We also have side D for blueprint.
So the travel of garbage on this, would that be the garbage would come here, and the current would bring it to our pod. Once we would have it angled so that once the garbage hit this part, it would have a steeper angle to the collection pod, so we wouldn't have to use electricity to move the garbage, where we would just be using a natural force to move the garbage to us. As well then with the living pod, we have it so that we can rent it out to separate companies to